All right. Good morning. Very impressive. Thanks a lot for being there. Looking forward to this talk. I hope I can tell you something interesting, take you a bit on the journey on what happened on our cloud cost side, give you a couple of insights. It's a very short talk, so I will just broadly go over topics. Feel free to find me in the hallways today, tomorrow. If you have some additional questions, I'm always happy to talk about it. So let's dive into the topic straight away. We'll start with a short introduction, so just so you get a bit of feeling of where I'm coming from, what this is about. The examples I give today, they are coming from JobLift, the company I'm working for. We are basically a job board, so our main business is ingesting jobs in our platform and then serving them to job seekers again. We have a recommendation engine. We have this thing we call the import pipeline where we ingest the jobs. We have a lot of machine learning where we classify the jobs. We are running on Google Cloud, so a lot of the examples, they are very close to Google Cloud, but they will apply to any other kind of cloud providers as well, such as Azure or AWS. We have a microservice architecture mainly based on Java and Python service, a couple of Node.js services running on Kubernetes. So this is kind of where I'm coming from. Let's look at what the practical experience looks like. So these are our cloud costs, basically starting in January 2021 until August 2024, so just last month. We had a couple of times I'm not so really proud about where we hit the 100K cloud costs per month, so quite a bit. And it's not as if our revenue would have been that much higher as it is today. Today we managed to be around 30K, which is still pretty high, but given that we have a lot of machine learning running where we also have GPUs, I think that's quite okay. So this is the journey. The main part of the journey started last year in November. So just to show a bit where the practical experience comes from. So now, before we dive into what can I actually do on cloud costs, let's look at how can we get started. Like what is the problem, right? So from my perspective, the very first thing is to actually see, well, okay, we have a problem. And what does it actually mean we have a problem, right? What does it mean my cloud costs are too high? And I think there are very, very different angles you can look at it. There's the angle we unfortunately had to look at it a bit, which was like, yeah, startup, we got a lot of funding, and then all of a sudden the funding gets less and less. The money starts not running out, but getting less on the account. So you start looking at the big chunks of money you are spending. On 100K a month is a lot of money. So you start looking into it without actually realizing that there is really a lot of saving potential. That's a bit the angle we come from. Then there's, of course, the angle where you closely can relate your cloud costs to, for example, the goods you sell. If you know, theoretically, if I have 10 users, I should have this much cost, and if I have 1 million users, well, it should just linearly scale up, and that wasn't the case. All of a sudden, it got much more, or we have much less users, but the cloud costs exploded. That could also be a sign, right? But in general, the first thing is to acknowledge that there might actually be a problem. And then there's a bit the question, okay, now I have this huge amount of cloud cost, this huge bill where my executives are sitting in my necks and telling me, hey, we don't want to pay this bill anymore. Should we get out of the cloud, get it down, whatever? So me as a person that needs to look into where do I actually get started? So personally, I'm a big fan of visuals, right? If I see bar charts, my brain can identify those patterns, right? If I have something that goes up, something else that goes down, and things that I think they should correlate don't correlate. So I think it's very good to start with actually breaking down your cloud costs, right? This can be by project. So for example, in our case, we start by separating into production and staging. Then we start breaking down a bit. For example, we might have one project for machine learning things, one project for Kubernetes cluster, a project for the CDN, right? You can split down in projects. Then you can split down very easily in services, right? Compute costs, for example, if you have Postgres, MySQL, so in general SQL instances. If you, for example, we are on Google Cloud, we use BigQuery and Bigtable, those would be services. And then you can even break down smaller in SKUs, so for example, network traffic or disks or CPU or memory, right? So the very first step is breaking down the cloud costs. Then something I also found super useful is labeling. So labeling for granular insights. For example, in our case, with one of the not so recent Kubernetes updates, you had the possibility to actually use those labels to break down the costs and the usage. So you can label your services. In our case, we labeled them, and then this allows you to actually know, hey, this microservice costs us this much in compute engine costs. And then there are a lot of tools out there, a lot of dashboards. There are commercial providers you can use. Most of the cloud providers, they already provide some nice dashboards. In our case, for example, we use Google Cloud, but we have a reseller do it. They offer some very nice dashboards that are pretty decent and allow to give a very good insight. So let's look at a couple of examples what this looks in practicality. So these are our cloud costs broken down by service, and one can already see, yes, the biggest chunk is, for example, compute engine, the blue bar up there. I don't know. Does this thing show? No, it doesn't. But we can also see that, for example, every 10 days there's like something going on our BigQuery, right? So that's what I meant with you can identify those kind of patterns when you break down things and then you visualize it. As another example, this is, for example, we labeled our Kubernetes deployments that we had, or microservices. So these are not all of them, but a bunch of our microservices. And then we have the compute engine resources, and then we split them per month, and then we can see what they actually cost, right? And then you might have that one service, and you're like, shit, that service actually costs 11 euros per day. That's quite expensive, or per month, right? So it really helps splitting those things down. And this is another example of those very neat dashboards that we get by DoIt. Our reseller, this is, for example, our buckets, our storage buckets. So we label them, and also here you can see, oh, I have this one bucket where I just stored my test data. Why is this actually costing so much? I don't need it anymore, right? It helps to identify those kind of patterns. So now we know, okay, we have a problem. We know where the money has come from. I want to give a couple of possible optimizations, so things that you can look into, things that make sense to look into. Let's start with Kubernetes resource optimization. Not always cloud goes hand in hand with Kubernetes, but very often it does. In our case, it did. So we are running Kubernetes. And for Kubernetes, basically, you pay for the CPU you use, you pay for the memory you use. And if you are a startup like we are, and you want to enable your developers, and you want to make everything fast, very often you give a lot of rights to the developers, right? So in our case, for example, the developers, they are responsible for, you build it, you run it, you deploy it, you monitor it, whatever, but they are also responsible for saying, hey, I need this much CPU and I need this much memory, right? So that gives a lot of freedom. But it also does come at some cost. So CPU and memory allocations, they are set during the initial deployments, but needs actually might evolve, right? You deploy a service, it has this huge process going on, and after 2 years, you remove that functional part of the code, but you forget to adapt the CPU resources, for example. Another problem is nodes. So you have those nodes, and you say, okay, this is a node with, let's say, 8 CPUs and 32 gigabyte of memory. And if you don't need them, well, you still pay for them, right? Because you kind of get the full node. So the solution is to, from our perspective, is, well, monitoring, right? It's all about monitoring. I will show some examples. So monitor how much, what are the requests you have, what are the actual usage you have, and then see to get them as close as possible together. I also think it's very important to kind of integrate that into daily operations, right? If you have a Kubernetes cluster in general, you have some kind of daily monitoring going on. And I think it's very easy to just integrate it there. Like have a graph, just it takes 3 seconds to check everything seems okay, and then it's fine, but it takes also 3 seconds to see, well, something is a bit off here. Let's maybe look closer into it. And then also in general, keep an eye on the unallocated resources. This example here is actually a Grafana dashboard we use. It's built on just the Kubernetes metrics. We put them into Prometheus and then read it from there, but also you can get them from the cloud providers directly often. So basically, the upper one is CPU, it's CPU, memory, and the lower one is CPU. The red line on top for the memory is actually what is the limit of the pot we are looking at here. The yellow one is what it actually requests, and then the line below is like the average and the maximum. And below, the green line is the CPU, the actual usage, and the yellow one is what the service requested. And ideally, you get those lines close together. So for the bottom one, for example, you can see that very often the service requests much more than it used, so one could definitely optimize there, but there are some peaks, so it's about finding a bit the sweet spot, but this is mostly about showing how such a monitoring could look like. Another example from Grafana, this is the nodes. It's one of our clusters where we have auto-scaling enabled also for the nodes. So the green one is basically the node resources. It's a CPU in this case, the cores that we have available. So it's scaling up and down. The yellow is what the services are actually requesting, which is pretty close to the green, which makes sense because it's auto-scaling here. And the blue one is what is actually used. And ideally, you have the blue and the yellow one close together, but also the yellow and the green one. On this one, it doesn't look too bad. Certainly room for improvement, but could be worse. This one is one of our what we call stateful node pools. It's basically a node pool where we say, okay, we request, 16 CPUs. But you can see already that here the gap between the yellow and the green one is quite big. And we pay for the green one, right? But we basically use the blue one. So that's already a bit of a problem. So it makes sense to actually find the machine types that are relevant and look into this. A second room for saving is always the commitment discount. So what are commitment discounts? Most cloud providers offer them. For example, on GCP, they are called CUD. On GCP, CUDs, committed usage discount. So basically, you tell them up front for a longer period, usually it's 1 year or 3 years. You say, hey, I know I'm going to use for the next 1 year, I am going to use 10 CPUs per day, every day. So I commit to using that, and I will pay that, but you get a discounted price. So that usually gives quite a good cost saving. It helps you predict the cloud cost, but it has the big disadvantage that you are locked into a commitment. If your business model changes, or if all of a sudden there's something like COVID hitting or some wars and your business goes down much more than you expected, you are locked into those commitments, right? So the thing is to find kind of a balance. The advantage to them also is that you actually need to think about it, to think, okay, where am I going to? You're forced to kind of look at it, but you can save quite some money with it. And the third option is discounted computing resources. So on AWS, you might know them as spot instances. On GCP, they are called preemptibles. On Azure, it's also spot VMs. So basically, it's kind of excess capacity that the cloud providers are offering you for much cheaper prices. So we use this a lot for our auto-scaling. So we have those microservices. They basically don't care if they are shutting down regularly. They are built for it. Because they are not always available, right? So it could be that the node disappears. You, of course, have the usual shutdown hooks and so on. But you can save a lot of money. Usually it's really worth looking into it, especially if you have some kind of instance running. There's also a risk to it, right? If you have services that need stability and all of a sudden the node goes down unexpectedly, isn't really good. And last but not least, the big cost factor often that is kind of falling a bit under the table is the network costs. So those can, if one doesn't pay attention, get out of hand pretty quickly. One thing that also always costs money is like network transfer between zones, right? For example, if you have one cluster in Frankfurt and one in London, they communicate, your cloud provider is going to charge you for that, so try to keep it close. CDN often is also a problem, so keep them close to the user. Also here, monitoring and reducing, of course, the interzone traffic. But also, like, we had the problem that two services within the same cluster, they were talking to each other, but we had a load balancer, so we every time paid the outgoing traffic. So these kind of things is actually was looking at it and not letting them fall under the table. So, coming to the end already, 20 minutes pass fast. What are the risks and what are the lessons learned? From my perspective, one of the biggest risks into this is you actually get addicted to that, right? You start, and then you see that your cloud costs go down from 10,000 a day to 8,000 a day, and then to 7,000 a day, and then all of a sudden you come addicted. Come on, I want to do the 5K, I want to do the 3K, right? So you can get really addicted to it. There's a bit risk that you overcommit on CODs. I mentioned it before already. We also went a bit too aggressive sometimes in under-allocating resources. So we were looking at the CPUs and we were like, yeah, I can give this a bit less CPU, and then all of a sudden it actually became a problem. You risk that also you commit technical debt. For example, in our case, where we actually needed to save the money, we were shutting down quite a bit of our staging environment. So it used to be kind of a pre-prod. Now it's really a testing environment with sometimes shitty data because we put it down a bit. So this kind of obvious decisions you take to go for the technical debt. But there are also some interesting learnings. So I think the very most important part is to monitor, to create alerts, to be prepared to adapt to them. Look at it on a daily basis, right? Because generally cloud costs don't explode from one day to another, but all of a sudden you see a pattern going up, but you didn't change much. It's worth looking into it. It's definitely also a journey. It's not a thing you do once and then you leave it. And it's also a mindset thing, right? Also, it's easy to request more CPU and more memory, but it also should be part of the mindset to not let the costs explode. And then that was it already from my side. Thanks a lot for listening.